Yes, good afternoon, students. Am I audible? Am I audible, students?
Good afternoon, sir.
Yeah. To mark your attendance, attendance is already scheduled. Just a minute, I am uploading PPT. Okay, so am I clearly audible or there is background noise? I hope the noise problem is not there much today, though I'm working from laptop. Yes, students, will I mute? Even on the YouTube also. Just wait, students. I'm connecting through mobile. Hello students, am I audible here? I'm trying to connect from my mobile, but I am not able to connect. I think if it is I'm audible with little noise, then we shall continue from here only. Lot of background noise is there. I'm trying to connect to mobile, but it is not getting connected. Okay, finally I got connected to mobile. Uh, I hope I am audible now, loud and clear, or still there is noise. Hello, students. Am I audible?
Audible, sir.
Yes, sir.
Okay. And whether the noise was reduced? Hello, students. Am I audible now? Okay. Let us see the last point from this particular unit, which is some system that is based on 8051 microcontroller or any microcontroller, but specifically because we are going to study 8051 microcontroller, so we take this as a system that is based on 8051 based uh, temperature control system. Okay, so here temperature controlling is taken as one of the example, but in this particular fashion, we can design any of the control system based on the microcontroller. So the microcontroller is at the heart of this particular system, and there are various ports available with the microcontroller, and you need to interface various devices, input output devices, to build a particular system. So what is required for a temperature control system? you need to measure temperature. Okay. So for measuring the temperature, you need to take a temperature sensor. So there are many temperature sensors available. So the appropriately you need to take the temperature sensor. Though here the complete circuit, other circuit has not been shown here. Usually the output of the temperature sensor is very low. Many temperature sensors, what they do is that they sense the temperature and convert the temperature into the voltage. That particular voltage is very low voltage. Usually it is in millivolt, and in that case, that particular millivolt is to be converted to the volt by using some signal conditioning circuitry. Okay, so some signal conditioning will be present, and output of that particular signal conditioning circuit will be in the volts. For example, 0 volt to 5 volt. So that particular signal conditioning circuit is designed such that as the temperature changes between certain range, for example, if the temperature changes from 0 degrees Celsius to 100 degrees Celsius, then the circuit here, the signal conditioning circuit here, will be so calibrated that its output will change from 0 volt to 5 volt. Okay, so and that is analog voltage. So there is a difference between analog voltage and digital voltage or digital signal. Usually the digital signal has got only two levels, that is 0 volt and 5 volt, but the analog signal, it has got infinite level between the two levels. For example, when we talk of analog signal ranging from 0 to 5 volt, then in between 0 to 5 volt, it will be having infinite levels, that is 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, like so like that. It can be 1 volt, 1.1, 1.2, even one between 1.1 and 1.2, there can be again levels 1.11, 1.1, and like that. So like that, we can have infinite levels. So that such signal is called the analog signal. So the analog signal that is ranging from 0 to 5 volt can be given to the ADC. Okay, so this ADC is analog to digital converter. So input to it is the analog signal ranging from, let us say, 0 to 5 volt. There can be infinite levels between 0 to 5 volt, and that analog signal is corresponding to the temperature. Okay, so for example, we have uh, here calibrated this particular circuit such that for 0 to 100 degrees Celsius, the voltage will be 0 to 5 volt. Okay. Again, many temperature sensors, they are not linear. That means as the temperature changes linearly from, or it adds the temperature changes from 0 to 100 volt, then the output voltage should change from 0 to 5 volt, and that particular graph between the temperature and if we plot a graph between the temperature and the voltage, then that should be a straight line passing to origin, that is 0 degrees Celsius and 0 volt. But if the temperature sensor is not linear, then that particular, it will not be a straight line and it will be a non-linear graph. And in that case, you can take certain measures to make that particular graph linear, or you can use the temperature sensor which is almost linear. So anyway, so if we say that if it is fairly linear, then 0 to 100 degrees Celsius is now converted to the temperature sensor and the signal conditioning circuitry to the analog voltage 0 to 5 volt. Okay, so like this, many of the quantities which are available in the real world, they can be converted into the analog voltage in this particular fashion. So you have different sensors. For example, your pressure sensor, your water level sensors, you have the humidity sensor, you have the moisture sensors. So like that, there are n number of sensors, and those sensors can sense that particular physical real world quantity and can convert, and they can convert that particular temperature into or in that particular physical quantity into the analog voltage. Okay, so then comes the role of the A to D converter. Okay, so after the signal conditioning circuit and the sensor, then comes the A to D converter. So what is A to D converter? It is analog to digital converter. So its short form is ADC, analog to digital converter. So it converts the analog input into the digital data. Okay, for example, here analog input is is ranging from 0 to 5 volt, okay, infinite levels, and it will convert it to the digital output. So usually the digital output of the ADC, it is 8 bit. Okay, sometimes it may be 12 bits or it can be even 16 bit. So because 8051 microcontroller is 8 bit, so we choose usually the 8 bit output. I hope I am audible, Shubhangi. Any uh, problem? You are not audible, Shubhangi. Yes, was there any problem? Somebody unmuted. Hope I am audible to all of you.
Yes, sir. Audible.
Okay. So if somebody unmute, then I get disturbed. Uh, so coming back here, the A to D converter will convert it into the digital data, and that digital data can be 8 bits, 16 bits, or sometimes it can be 12 bits. But for the 8051 microcontroller, we choose the ADC. There are a lot of ADCs in the market. For example, 0809 ADC 0809 is one of the popular ADC, which has got 8 channels. 8 channels means 8 analog inputs. There are 8 analog inputs, and there is one digital output. Okay, so uh, you can, that means it can accept the input from 8 different sensors, you can say. So here only one sensor has been shown, but if this ADC is 0809, then input from 8 different sensors can be taken, and at a given time it will convert the one input to the digital output. Which input to be converted to the digital output is selected by the microcontroller. So microcontroller will ask the ADC to select a channel. That complete interface, or that those particular control lines have not been shown here, but you can understand that the control signals are also going from microcontroller to the ADC, that is A to D converter. Only the data flow has been shown, that the data from the temperature sensor goes to ADC, analog data, analog A to ADC converts it into digital, and it goes to the microcontroller. But there are other control lines also not shown here, which goes from the microcontroller to the ADC, that is analog to digital converter. Okay, for example, the microcontroller will ask ADC to select some channel on which the temperature sensor is connected. After it is selected, then it gives the command to the it gives command to this particular ADC to convert uh, this to convert the selected channel to analog input to the digital. Okay, so that particular command is called start conversion. So ADC has got an input that is called start conversion, and that pin is usually labeled as SP, that is start conversion. So after the start conversion, command has been given or signal has been given by the microcontroller to the ADC, ADC start converting the analog input to the digital data. Okay, so from the selected channel. So after it has been converted, its output is ready on it outputs is ready. Then uh, ADC has got the output EOC, that is end of conversion. So with its output end of conversion, it can tell the microcontroller that the conversion is over. So upon that, the microcontroller will read or will be keeping on reading this particular EOC, or this EOC may be used to interrupt the microcontroller, and upon interrupting or upon finding EOC line of ADC high, that is end of conversion is over, the microcontroller will read that particular digital data. Okay, so this particular ADC converts the analog input into the digital. So what can be its output? For example, the input to the ADC is 0 to 5 volt. So corresponding to that, the output of the ADC, which is 8-bit ADC, can be from 00H to FFH. Because it is digital, it will be in binary. So represented in hexadecimal, the output of the ADC will be 00H. That is, if input is 0 volt, then output will be 0000. Uh, that is 8 times 0. Whereas if the input to the ADC is 5 volt, that is full the maximum, then the output of the ADC will be all ones, that is 11111111. That is the maximum output the ADC will have. Okay, whereas if the input is in midway, that is, let us say 2.5, then the half of half of FF is 7F, that is 127 or 128. So that will be 7F or 80H. So like that, it will be, let us say, 80H. For 1.25 volt input, it will be half of 80, that is, it will be 40H. If it is again half of 1.25, 1.25 is 0.62 something, 0.625 something. So in that case, half of this half of 40H is 20H. So like that, the output of the ADC will also change. Okay, but it will be in binary. For example, 20H is in hexadecimal, but in the binary it will be 00100000. Okay, so as the input changes, there will be change in the output of the ADC. Okay, so depending on how many bits you have, there will be some resolution. That means what change in the analog input can make the LSB change in the output of this particular ADC, determines the resolution of this particular ADC. If you want high resolution ADC, then you need to increase the number of bits. So instead of 8 bits, you can have 16 bits, or or 12 bits is even the high resolution than the 8 bits. Okay, so like that, the temperature that is converted into the digital data, for example, 00H corresponding to 0 degrees Celsius, and FFH corresponding to the 100 degrees Celsius. So that is given to the microcontroller. Okay, and you can use any port of the microcontroller to interface this particular ADC. So to interface the ADC, you need at least one input port with 8 lines. So for example, port 0, all 8 lines you can connect to connect the data. Whereas to connect the start, to give the command start conversion, to read the end of conversion, so some lines of port 1 can be used. Okay, for example, one line can be used for start conversion. So that is the output of microcontroller going to the ADC. End of conversion, that is output of the ADC, that is going to the microcontroller. Okay, and if more than one temperature sensors are there, for example, you are reading the temperature at different places, at 8 different places, say, then you'll have to select one of the temperature sensor in that case. So another 3 bits will be running from microcontroller to the ADC. So this particular 3 lines will be indicating which particular temperature sensor is to be selected. Okay, for example, 000 will select the temperature sensor 0, 001 will select the temperature sensor 1. So like that, there can be 8 different temperature sensors, and their IDs will be from 0 to 7, and the microcontroller will be telling ADC to select its one of the 8 channels. So in that case, ADC will be having 8 different channels. Okay, so like that, any of the temperature at 8 different places can be read by the microcontroller, and it can be stored into the internal RAM of the microcontroller. Okay, so that is what is the input part. Okay, so you have the input part where you read the temperature at 8 different places. Okay, at the output, what you have is the LED, or sorry, here it is LCD. So because you have LCD, so it is possible that you can display the temperature. So if it is only one temperature sensor, you will display the temperature sensor, the temperature at that particular point. If you have the temperature sensors at 8 different places, then on the LCD you can display that at point 1, or in room 1 the temperature is this, at room 2 the temperature is this. So like that, it can be a scrolling display, or it is possible, if it is required possible, or if you want, then all the 8 temperatures, they can be displayed simultaneously. So the 2 lines of the LCD display can be suitably divided such that the temperature of all the 8 places can be displayed simultaneously. Okay, so it is in the hands of the programmer whether to display at a time all the temperatures, or to display boldly the temperature of only one room at a time, and then it will scroll. Then it will display the temperature of the second room, third room, and like that. Okay, so the actual temperature can be displayed over here. In addition to this, this particular display can be used to indicate whether you are going to put on the heater or not. Okay, so the way to control your temperature is the heater. Okay, so by using heater, you control that particular uh, temperature in that particular room. Okay, now this is one way that you are controlling the temperature, so indicating that always the temperature required is so it is pro- probably this particular system can be used in the areas where it is very cold, always it is cold, and you need to put on the heaters so that it comes to the temperature sensor. For example, in the Canada, country like Canada and all that. Okay, but in the country like India, particularly the South India, to control the temperature of some room, so instead of heater, you'd like to have for the pleasant uh, uh, room temperature, you need to drop down the temperature because of the external heat. Your room temperature increases, and instead of heater, you need to have the AC, that is air conditioner, or air which would be required for cooling. For if you are using air conditioner, that can be used for heating also, but the cooling uh, part of that would be more useful. Okay, so whether that particular device is on or off, so that also can be indicated on the LCD. If there are number of rooms, then instead of having a single heater or single air conditioner, you will be having number of heaters and number of air conditioner appropriately. So the one connection will be that one of the port line, for example, from port 1, you are using port 0 for ADC data, and some of the lines of port 1 for as a control lines for the ADC, then the remaining lines of the port 1, or you can use port 2 lines for connecting or for putting on or off this particular heater or this particular ADC, so that the temperature can be controlled. Okay, usually you do not give the output of the microcontroller to the heater or to the air conditioner, because air conditioner or heater, they operate on high voltage, 230 volt. So you use a relay. Okay, so relay is a mechanical switch. Relay is a mechanical switch. So to the input windings of the relay, if you pass the current, then in that case, that particular relay can be put on, and using that particular relay contacts, the heater or the air conditioner can be switched on or switched off. Okay. So usually you might be knowing relay, but you might not have seen the uh, relay, but you might have heard the noise of the relay in many of the automatic system. A particular sound comes, stuck sound comes, in which that particular something is automatically on or something is automatically off. For example, in the refrigerator, you might have heard that that particular sound comes, and when that particular sound comes, the compressor is turned on, and when the temperature is maintained, automatically it is turned off. Okay, so that particular relay is used. It is the mechanical switch. Again, to operate the relay, you need a transistor. Okay, so the output of the microcontroller, it is given to the transistor, and transistor, it is a current. It is used as the current amplifier. So transistor can be put on or put off by sending a high voltage or low voltage from the microcontroller. Okay, so like that, the heater or any high voltage device can be controlled by the microcontroller. So microcontroller will be sending only one bit in output. Okay, so by sending on a single line, so for example, port 2.0, so that particular pin, it can be by sending a single command set P2.0. This particular heater can be off, and by clearing that, that is by sending the command or by executing the command CLR P2.0, you can send a 0, and you can put off this particular appliance. Okay, so like that, any of the controller system uh, can function in this particular fashion. So this is only the temperature system, but in this particular fashion, through relay, you can you can control any of the device. For example, you can control home appliances, tubes, fans, the geysers, heaters, microwave ovens, and all these things in the households, or in the industry. Certain walls, they can be controlled, certain the pumps can be controlled. Okay, so there are many ways how you can use this particular microcontroller in the different embedded system. So a small example, a simple example of temperature control system based on the 8051 has been described here. So depending on the scope, you can go on increasing this particular diagram. So this particular diagram is drawn very simple to look, but if you want, then you can have more number of temperature sensors, or you can have heterogeneous temperature sensors. Not only temperature sensor, one can be pressure sensor, one can be level sensor, and like that. Okay, but the overall interfacing connections of that particular complicated system will be very similar to this one. Okay, and you will have LCD display, for example. It can be connected on port 3. Okay, so like that, you have four ports, and in all four ports, you have to manage all these things. Okay, so that is how one can build a 8051 based control system. Okay, and nowadays uh, the applications are coming such that this particular system can be controlled remotely also. Okay, for example, here this particular system we are telling is the standalone system. That is, the control is with this particular microcontroller program only. But it can happen that the microcontroller will not be controlling it, and it will be connected to the internet, to some dashboard, and from that particular dashboard can be opened from any of the mobile, or it can be opened from any of the desktop, and from there, under the user commands you can make this particular system to control. Okay, so it can be a remote monitoring system also, but in that case, of course, your microcontroller need to be interfaced to the remote. Okay, so one way of connecting it to the remote system is to the serial port. Okay, whereas the other ways they can be by interfacing it with some Wi-Fi module and like that. Okay, or it may be connected to some Steam module. But in these cases, in such cases, the instead of using the 8051 microcontroller, similar microcontroller other than this are used. For example, Arduino Uno is the microcontroller that is used, or Raspberry Pi systems are also used for the complex control. So you might have heard about these particular controllers, and in the IoT, you will be learning about this particular microcontrollers later in the detail. Okay, so here with this we stop here, and that was the last part in this particular unit. The two smaller parts they have remained, that is interfacing of the LCD, so that we shall see in the practical, and ADC and DAC also part time permit that we shall see in the practical. So otherwise, the PPT I have given all these things, or you can refer to the book by Mazidi. If soft copy is available with you, or otherwise you can take it from the college library. If I have a copy of it, I will share it. I have one PDF, but in that is only PPTs. I will share that with you. Okay. So today we shall stop here, and shall meet in the, the practical batches for the LCD interface. Okay. So that will be the last practical. So if any quick queries are there, you can ask those queries. Is there anything in the message box? Let me see. There are no messages. So we shall stop here. I hope all of you have marked your attendance. Okay, all of you may leave the meeting now. Class is over.